Hello everyone, and welcome to the next in our series of videos on functions. What we're talking about today is an important part of what a function is, because most functions can't really be discussed for any values. So when we look here, what we're really asking is, how do we discuss what you can and can't put into a function and what you can or can't get out? So for example, we've been talking about toasters in our video series a little bit, and things that would fall into things that are allowed as inputs into a toaster would include, rye bread and bagels, but definitely not scissors or your cell phone or an elephant. These are things that don't fall into the input. So if you just told me that you had a toaster, but you never described exactly what was allowed to go into the toaster, then there might be a really bad misunderstanding. And so we're trying to avoid those misunderstandings in math because we're very specific in math. And so in this particular case, we're going to try to describe everything you can put in and everything you get out. So for example, when you put a bagel into a toaster, you get a toasted bagel out. You don't get a shoe. So you'll never get a shoe out of a toaster because we're not going to allow you to put shoes in to begin with. So this is all about restricting what can go in and what can come out. So for that, we're going to start off with this example with pay. So we've got this pay here on this axis. So we've got 20, 20, 40, $60. And on this axis, this is the amount of time you work. So you got 1 hour, 2 hour, 3 hours. So for example, if you work for 2 hours, you get paid $40. Okay, when you work for 3 hours, you get paid $60. So I think it's pretty clear that you're making about $20 an hour here. So this is the equation you'd usually be presented with. But is this really enough to describe how this person is paid? Now, the other thing we notice is that you can be paid any of the values in between. You can you can work for an hour and a half. You can work for an hour and 15 minutes. Okay, you can work in all these increments in between up to to the second here, even smaller than the second because this line has no break in it. Okay, so you can be paid any exact amount here of those $20 for that hour. So we need a way of telling the reader that that's the case. So that's what this is kind of all going to get to. So, so how do we choose to write the information that you can be paid anything in the middle, for example? So what we use is what's called number systems for that. Number systems. And number systems describe sort of the gaps in between the numbers and which numbers belong to the set. So in our case, we want all decimals. So we know our number system, the all decimals one. Okay? So now that number system has a name. We call those the real numbers. Okay? So we want to say the input can be any real number. Okay? So our input here into our equation is the time. You put in the time, it tells you the pay. So this is our time, is going to be our input. So we want to say that our time belongs to the real numbers. Now we have a short form for real numbers. We're just going to use that. It's like an R with an extra line. But what we're really saying is real numbers. And what are real numbers? All the decimals. So you can have a half, a quarter, 0.2222221. You could have a non-repeating decimal. Anything that you want could go in there, really. Every number that you're used to. So we say that it belongs to the real numbers. But we have a symbol for that, too. This means element of. So the time will always be one of the real numbers, is what we're really saying. Now, more than that, we want to tell you that we're talking about the input. Well, we have a word for that too. When we're talking about the inputs that were allowed, we call those domains. So we're saying that the time is going to be a real number. Now, could it be any real number? Well, I think this time scale, right, is a little unclear. Is this time in a week? Month? Year? So I don't really know what an upper bound is right now for this. But I definitely know I want to have this to be bigger than 0. because we're not going to work negative hours. It doesn't even make sense. So let's leave this and we'll come back to it in a second. First of all, let's just talk about domain. We usually use a D for domain, and the domain is the set of allowable inputs. Okay? And the range, we're going to use this word range to indicate all of those amounts that we could be paid. So like we can be paid any amount between 20 and 40 for the times that we work between 1 and 2. Okay, 1 and 2 hours. Okay, and we could get paid more money. You see this arrow here shows us that we could be paid more. But we can't be paid negative, but we can be paid any decimal amount, right? Any decimal. So we're going to use range here to talk about our outputs. So it's the set of all possible outputs, given that we know there's only some allowable inputs, right? So before we come back to that other one, let's look at some other examples, okay? So these are some of the things you can use. So this symbol here, we're going to use for set of. This symbol here, we're going to say is such that. So this is when we say it can be anything except that it has to follow this rule too. So such that it follows this rule too. This is domain and range, remembering that domain is input and range is output. If we want to make something that can't be equal to something, we're use the not equal sign. This one we know, that one's the equal sign. Real numbers, those are all the decimals, right? All the whole numbers, everything. Let's just say everything. Just put every there. Now we have the natural numbers. Those are the numbers you count. Those are like 1, 2, 3, 4, 5, so on. We have the integer numbers, which we say are like -5, -4, ... to 0, 1, 2, and so on. Okay? We can also say we want something to only be less than something. Well, there's our less than symbol. Only greater than something, and there's our greater than symbol. Less than or equal to, we use that symbol there. Greater than or equal to, we use that symbol there. And then we have X is between, and this one we use a lot, remembering that this one's always going to be the lower number if we use our symbols in this direction. This will be our higher number. So now let's take a look at a couple of these. We have our machine that we talked about before. This is the do nothing machine, right? Takes numbers and just gives you those same numbers back out. So if we think of that machine, what could you feed into this and do nothing to? Well, you could feed anything you want in there, right? So we say our domain is equal to X can be a real number, any real number. So it belongs to the real numbers. And our range, well, what will we get out? Well, when you do nothing to a number, you just get that number back. And because you just get any, you could have put anything in, you have to be able to get anything out. So y is also just an element of the real numbers. Okay, so reading this back, when you read it, you shouldn't read r equals squiggly line, y e thingy, r with an extra line, squiggly line. Read it as the range is the set of all the y's that can be real numbers. Okay, which is basically any number you're used to. Okay, now when you square a number, so if we look over here, okay, we've got the domain equals, well, what numbers are you allowed to square? You can square any number you want, no matter what the number is. So once again, we're just going to have the domain as being anything you want. And when we come over here, though, the range is not anything, because when you square a number, if it's positive, a positive times a positive will give you a positive. But if it's a negative times a negative will also give you a positive. So this means that for the range, y could be a decimal, no problem there, except or such that y will always end up being bigger than or equal to 0. Let's take a look at a couple more here. Now these numbers here, okay, there's so few of them that belong to this set. There's so few of them belong to this set that one way of writing the domain and range is just to list them. -1, 0, 1, and 2. That's all of the inputs that we could have, all of these. Now the possible outputs then are, and we usually write them from smallest to biggest, just for convenience. So these are all the things that could come out. That's an easy way of writing that. Now I'm going to show you a different way of writing this. So the domain, exactly the same list. We could say x has to be an integer this time. Okay, because it can be negative or positive. It can be 0, but it can't be any of the decimals in between. So we use integer instead of real. And then we just say what we're in between. Okay, it could be from -1 to 2. So all of the integers, including -1 and 2, that are between -1 and 2. That's another way of writing the same thing. And if you want to practice that, try writing this like the way I wrote the domain. This one here is kind of interesting. We need to put some values in here. Let's assume this is -1. And let's assume that is 1, 2, 3, 4, 5, 6, 7, 8. And this one would be -1, -2, -3. That's going to be -4. 1, 2, 3, 4, 5, 6, 7, 8, and so on. And let's just think about what this could be. Well, the domain is what you're allowed to put in. So you can put in anything, but there are some things that we have to restrict. So one thing we want to say is that it's got to be bigger than -4, but because of this arrow, it keeps going forever down here. So we just have to say x is greater than -4, but not including -4, because this is an open dot, and that means don't include that spot. Okay, the only other thing we have to talk about is this spot right here. Okay, because this is 1, 2, 3, 4, and we're not allowed to be there because that's an open dot, meaning we're not there. We're not going to be there, okay? So x cannot equal 4 as well. And then we're done. Okay, now our range is all the things you could get out. Well, it looks like the highest we ever go is 8, and the lowest we ever go is -1. But watch out, because this keeps going. So we will go below -1. So we'll keep that in mind. Y is an element of the real numbers, such that y will be less than 8. But it could be equal to 8 too. There's no restriction up there. So it could be equal to 8. We're not allowed to be here. See how we're never at that height because that point's not included. So we're never at 6. So y does not equal 6. Now, you might be saying, what about this point? But when you look across, we are there. We do get to a height of 5. We get to it there and there. And it keeps going down, so we have no lower restriction. So there's our domain and range. Now let's get back to this idea of pay. So this is based on real life. So if we have P now represent the amount of pay for a week in dollars, and T represent the time worked in a week, well, now we can be a little more specific. So the domain is equal to any time, but you can't work less than 0 hours a week. You could work 0, but you can't work less than 0. So we're going to include it by putting the equals. But you're sort of stuck for time during the week. So I'm just going to go ahead. You need to notice something about this job to know for sure. But I'm going to say you have to work less than 44 hours. Well, what's the range going to be then? Well, the range is what you could get paid. And we said you could get paid some decimal amount, so we're good there. You can't get paid less than 0. Okay, so you can't get paid less than 0, but you do have an upper bound because we are saying you're working a maximum of 44 hours. So the most you could be paid is 20 times 44, right? Which would be $880. So $880 is the most you could be paid. And that will allow us. This tells us how much we get paid, and this tells us a lot more about the situation. Okay? It tells us all of the restrictions. So hopefully that helps you understand domain and range a little bit better.